G'day guys, how's it going? So in this video, we're going to quickly talk about strings, what they are, and how we store them in Rust. So firstly, what are strings in Rust? Well, the definition in Rust is it's a sequence of Unicode characters represented as a vector of 8-bit unsigned integers. A little bit cryptic, right? But primarily what people think about when they think of strings is storing text. Now, in Rust, that we do have this UTF-8 encoding supported out of the box, so every string is factored in that way, which is a little bit different to other programming languages, which I'll speak about in a minute. It's stored just as a vector, so as a result of that, the strings are going to be stored on the heap. So it's just something to keep in mind. And just like I said a moment ago, languages out there that are not Rust usually store a string as like an array of characters or a list of characters, right? So as a result of that, you could normally go through the process of capturing an individual character in that string by using indexing. With Rust, we can't do this, okay? So it's just something to keep in mind when you're first looking at strings. In Rust, it's a little bit different to other programming languages. And then lastly, because it's a vector, we can slice up a string and create our own string slices. And in fact, it's quite encouraged to do that in your code, as we will see in a later video. Now, how is it stored? We kind of explained it just a moment ago, but because it's a collection of unsigned 8 integers, you can see in the heap memory on the right hand side, I've shown you the character or the byte code for an individual character. So 72 for a capital H, 101 for a lowercase e, 108 for a lowercase l, and 111 for a lowercase o, right? And basically, as a result of that, to store the string hello, we have to use 5 different byte elements, right? So there's 5 overall items that make up the word hello, okay? Now, this is a simple ASCII example, but ASCII still is relevant with UTF-8. But what if we want to store something like an emoji, like we mentioned before, right? That looks like it's one individual character, but instead, what Rust does is it stores it as 4 different elements with byte codes in them. So the combination of 240, 159, 154, and 146 put together, if you decode that and convert it, it'll end up representing itself as a fire truck emoji in this case. So that means that fire truck emoji up there has a length of 4 bytes. All right, so hopefully that makes sense. So now that we understand how strings work, let's just quickly jump into the code and see this for ourselves. All right, so I've got the code open, and what we'll do first is we'll create a string, and then I'll show you how it's really made up as a collection of bytes. And then we'll take a few bytes, we'll convert that byte to a char, and we'll indicate that under the hood, that's what that byte is representing. So we'll start with that first. So let's go let a string equals string from, and I'll go hello world. Cool. And then the next thing I'll do is I'll convert this into a vector of bytes, because at the moment we're just working with a string type. We can convert this to a vector of bytes by going let a string byte vector equal a string dot as bytes. So what this will give me now is, as you can see there, a reference to an array of unsigned 8 integers, right? So now let's get the first bytecode. So we'll just go first letter byte code, and we'll set that to a string byte vector, add 0 index. And then let's get the last letter, which we know will be the 11th character in that collection there. So we'll go last letter bytecode. And now if we want to just convert these to the first and last letters, we can go first letter, let's say char equals first letter bytecode as char. And I can do the same thing for the last letter. Now, hopefully you understand what I just did here. Essentially, all I did was convert the string type to a vector of unsigned 8 integers, or a reference to an unsigned 8 integer. So we haven't transferred ownership. And then I've just grabbed the first byte from that vector and the last byte from that vector. And now I'm showing what the characters are. So what they should be is a capital H for first letter char and the exclamation mark for last letter char. Right, so let's print all these things out just to confirm that. So print line, a string, and then we'll go string vector first, like that. So now I'll just go through and print all these out. Like so, whoops. Cool, so if I now, oh, what happened here? Ah, sorry, wasn't meant to do this one. We don't need to see it. Well, actually, if you want to see the whole vector, you can. Let's do this. Let's go and print out the whole vector. Cool. So if I run this now, we're going to get a compilation. I'll just quickly bring this up. So there's our hello world text. Here is the unsigned integer vector that represents that piece of text. Then you can see we got the first byte code and the last byte code, and the equivalent was a capital H and an exclamation mark. Cool. So that demonstrates that a string is just literally a vector of unsigned 8 integers. That's what I wanted to demonstrate there. Now, this works for ASCII, the character set, but if we want to do that same emoji example that we saw before, let's do this. So let's go let fire engine emoji byte, oops, spell it right, bytes equals a vector, whoops, and we had 240, I think it was 159, 154, and 146. So these 4 bytes made up the fire engine emoji. Cool. So then what we need to do is we need to convert this to a string, right? So how we can do this is we can basically use an if-let statement, and we have this concept of okay, not sum. So when we do a conversion from a vector of bytes to a string, it returns this thing called an okay. I won't talk about it just at the moment, but just know it's like a sum. And we go fire engine emoji, let's say string, right? So we're unwrapping to that string there, and we go equals string from UTF-8. Remember, because everything under the hood is UTF-8 encoding. So then we pass in the fire engine emoji bytes. So if this works, well, let's print it out, So print line, we'll say converted emoji string length, blah, blah, blah. So let's just make sure it's actually, I spelled emoji wrong again. Let's check the length of the actual string here. So fire engine emoji string dot length. And let's then print out the string itself, right? Oops. So fire emoji string. And while we're at it, let's get the first byte. So we'll go back the other way just to confirm that the first byte is what we expect it to be. So first byte is equal to fire engine emoji string. Once again, we'll call as bytes, and we'll get the first value, and then we'll just print that out. And that should equal the 240 at the up the top there, right? Just indicate that it is, in fact, the same character set underneath. First byte. Cool. So let's just give this a little run. And there you go. We got a little fire engine. It says converted, spelled wrong. Converted emoji string length is 4. So it's acknowledged that this string has a length of 4 based on the fact that it takes 4 byte codes to generate the fire engine emoji. I'm going to change that to N. I don't like spelling mistakes in my code. And then it shows that the first byte was 240. And if I was to change this to say, I don't know, 3, so I guess the last one, then it'll get 146, right? So you get the idea. So that is how you can convert a set of bytes to an emoji. If you really wanted to do that, you can do that too. And then just to indicate that we don't always need 4 bytes to create a string with a value in it, we could make a single byte. Let's just quickly see that in action. So what I might do here is go let single bytes equals, and we'll create a vector, and we'll say 125, right? So 125 is going to map to something in ASCII, and then we just do the same here. I might rename this to a single byte string. We'll get rid of the converted for a second. And so we'll print that out. We'll get rid of all this. And let's see if it prints something out when we do this with just one single byte. And the answer is it does. It actually prints out, believe it or not, a right curly brace. Now, if I change this to something that doesn't work, say, let's go 400. All right, so 400 is a really high number. And in fact, it's going to complain because that's like the range of U8, of course. Let's do 127, I believe. I think that's one that doesn't work. And now we get nothing. See? Nothing shows up. And in fact, just to prove that it doesn't actually allow this to encode, let's do an else statement just to see that it hits the else and go, could not get a string from the bytes. Cool. So if I run this, and in fact, we didn't get that error message. So it did return something interesting. Okay, so it returned a till then. Try to remember, there was a given character that or maybe it was, hang on, maybe it was, I had to do something like that. Maybe not. Let's try something really weird like that. There you go. Could not get a string from bytes. So basically this byte array is not something that can be correlated to a UTF-8 encoded string. So as a result, it doesn't generate an OK. It falls into the else block and then says you can't get a string from the bytes. Cool. So let's leave it there for now. But in the next video, we'll start looking at some functions and some methods of strings and what we can do and how we can mutate strings and iterate over strings and things of that nature, right? Well, we'll do that in the next video. So I'll see you then.